Today we are discussing chemical reactions and equations, class 10, chapter 1, science. So here chemical reactions and equations. So here we will be discussing chemical equation, balancing chemical equation, types of reaction, oxidation reduction, and corrosion rancidity. That is the final one. So let's start with the chemical equations. So here, okay. So chemical reaction is a process in which the atom of one or more substance reactant are rearranged to form entirely new substance or product. So what happens in a chemical reaction? Reactants combine to form the product, right? So it may be the new chemical bonds replace the old one. So what happens? The new molecules form, and with the help of like it may be because of the heat or the sunlight or any other external factor should be required, right? So everyday life runs on chemical reaction like digestion of food. We may not be recognizing that chemical reaction is happening, but actually very simple day-to-day life, we whatever we see here, like digestion of food, burning of fuel, respiration in cell, then photosynthesis, all these are examples of chemical reaction. So 6 observable sign of chemical reaction. So chemical reaction, how can we observe that chemical reaction is happening? So first one, it may be change in state, like liquid forming a solid or gas. So that may be like state is changing from the liquid to gas, or change in color. So it may be silver iron nail turning brown. So that may be symbol of like a chemical reaction. Sometimes it change in color. Then evolution of gas, zinc zinc granules. If we just pour the H2SO4, then acid, then it will be hydrogen gas will be emitted. So that is also a sign that chemical reaction is happening. The change in temperature, the mixture gets hot or cold. So that is also there. Sometimes what happens, if we mix two things, which we see that the temperature changes. So formation of precipitate, sometimes white precipitate or different types of precipitate comes out from the solution. Then formation of light, what happens, like magnesium, if you burn the magnesium, and then what happens, we see that brilliant light we see, right? So example, so this what we can see, example, a clean magnesium ribbon burns in air with dazzling white light and turns into white powder. So that becomes the from the magnesium. What new product is there? The magnesium is the reactant, and what is the product? It's a magnesium oxide. The ribbon must be clean before it develops the dull oxide coating in most air, so which stops the metal underneath for burning well, right? So that is the example of the here magnesium ribbon burning is the example, a perfect example of chemical reaction. So what are the signs of how do we know that chemical reaction is happening? So here changing the state, color, evolution of gas, change in temperature, formation of precipitate, formation of light. So all these are the symbols of this type of reaction, chemical reaction is happening, right? So let's move ahead and see chemical equation. Now next topic is chemical equation. So chemical equations, here, see, chemical equation till now what we have learned is it is in the form of word equation. So what is the word equation? You can see here word equation. So this is magnesium plus oxygen, what it combined to form magnesium oxide. So example is here. So this is magnesium. Just now we have seen magnesium ribbon and oxygen. It dazzling like bright color. It comes out. So that is the magnesium oxide. So this is a word equation example, right? This is the example of word equation. Reactant and product written in the full words, easy to read. So what is the advantage? Easy to read, anyone can read, but not precise about the quantity. But we don't know that what quantity of magnesium and what quantity of oxygen will mix to form magnesium oxide. Then skeletal equation. Second comes the skeletal equation. Here the simple magnesium and oxide we will write, and it is going to give us MgO. So if we write like Mg plus O2, and it is giving to MgO. So this is the example of skeletal equation. So here what is happening? Here it is not balanced. This equation is not balanced, right? Formula used to instead of name. So here we are using formula, chemical formula, but atoms counts are not equal. We can see that here two oxygen is there, and here only one oxygen is there, right? So this is the skeletal equation. And what is the balance equation? All the counts of equal. After this one we have to balance it, like here two oxygen is there, here only one oxygen. So this will be, it will form we have to balance this equation, right? So that all atoms should be equal left side or right side. So that is called balance equation. So balance equation example, law of conservation of mass, because it has to follow law of conservation of mass. All like here two atoms of here oxygen is there, but here only one, here two, but here only one. So that's why here you can see everything is balanced. Two magnesium, and here also two magnesium. Oxygen two atom, here also oxygen two atom. So this is the balance, right? So making equation more informative, symbol heat. And so how do we write? Like for heat we will be writing like triangle kind of thing here, symbol. And sometime what we write here, magnesium, so here we can write solid. This one we can write in the bracket gas, right? Sometimes aqueous. So here liquid form, catalyst name over the arrow. And if there is any catalyst, then also we can write gas evolve. So that will, you have to, if gas is evolving, suppose H2 is coming out, right? Then we have to write, sometime we can write this way also. Okay, so this is the chemical equation we have seen, word equation first we have seen, then skeletal equation, and finally balance equation. Balancing a chemical equation. So how do we balance the chemical equation? So here with the help of example we can see, because balancing is very important, because it has to follow the law of conservation of mass, right? So it has to, so how to do it? Let's see with the help of one example here, this one. H2 here, H2 plus O2 is 2H is H2. So two atom of here two atom of oxygen, and here only one atom. So what we are going to do, balancing oxygen, we are going to balance oxygen. So here two, here only one. So here we are going to multiply two here, right? So now what is happening here, total 4 hydrogen atom is there, here 2 hydrogen atom is there. So again we have to multiply here 2 by 2, because we have to make it 4 hydrogen. So 2H2 plus O2, 2H2O. So we can see here, we in the bracket we can write, this is the gaseous state, this is in the gaseous state, and this is the liquid state, right? So method used above, there are several methods to balance the chemical equations, but here we are using heat and trial balancing. Pick the element appearing the fewest compound first, adjust coefficient one at a time. So how we have started, we have started with the oxygen, right? We have started with the balancing of oxygen atom, and then what we have done, pick the element appearing in fewest compound first, adjust coefficient one at a time, and recheck every atom before finishing. So finally, because in the final step what we have done, we have seen here hydrogen is here this side 4, and here only 2, right? So we have multiplied by 2, and so finally this is the balance equation. So this is the so what we have done, this is heat and trial method, but there are some other method also that we will be seeing later on. Okay, so now after this one, different types of reactions, right? So some famous, these are very popular reaction. Let's understand this. So combination and decomposition reaction. So combination reaction is, suppose reactant A is there, reactant B is there, and finally it is AB, right? So suppose calcium oxide is here and H2O is. So calcium oxide and water, it will be creating calcium hydroxide, right? So quicklime and water. So here it is, so this is a exothermic reaction, means what is happening here, A and CO and H2O, both these things are combining to form COH2. So this is exothermic reaction here. So this is combination, right? A plus B, here A and B, and making AB. Then similarly, carbon in the solid form on oxygen, it is creating CO2. And burning of coal, this is what happens when coal burn. So that is a CO2. So that is the another example. Then 2H2 plus O2, here it is balanced. Just now we have seen how to balance it. Then formation of water also happens with the combination of H2 and O2. So that is H2O. So this is also combination reaction. So three combination reactions we have seen here. Then comes decomposition reaction. What is decomposition reaction? So decomposition reaction, suppose a reactant is such that it is and such that if we heat it, or with the help of some other reactant, with the help of some catalyst or anything, if it decompose into two parts. So product is, reactant is AB and product is A and B. So suppose example is thermal decomposition. So CaCO3, calcium carbonate, if we heat it, this is the sign of heating triangle, it will be forming CaO plus CO2. So that is decomposition by heat. Then electrolytic, we may decompose it with the help of electrolysis, right? So H2O, if we pass the electricity, then it will divide into hydrogen gas and O2, right? Similarly, photolytic, so AgCl, how it will in sunlight, it will be decomposed into Ag and Cl2, decomposed by light. So everyday link here, silver bromide or chloride. So this is silver bromide, Ag bromide, AgBr or AgCl, right? Used in black and white photographic film, decompose it in sunlight. So how it decompose it in sunlight? Decompose in sunlight. So how it happens? So it will be Ag plus bromine, right? So can we balance it? So bromine is there here, right? So here also what will happen? Here also 2, right? And here, because now 2 Ag this side, so 2 atoms Ag here also. So this is the balance equation. One is given, the other one we can write our own. Okay, so after this one, let's go to the next one. Displacement and double displacement reaction, right? So let's understand what happens in displacement reaction. As the name suggests, suppose we have a compound like AC plus here A plus BC, and what is the product? AC, A and C combine, A and C combine here and make AC and B. So this is example of displacement reaction. Fe plus CSO4, it makes here FeSO4 plus copper. So what happens? Because here iron is more reactive than copper, so it will combine with the copper sulfate with the sulfate, and it will be a new product will be forming FeSO4, and copper will be precipitated. So iron nail dipped in copper sulfate. So what happens? Actually, iron nail dipped in copper sulfate, sulfate turn blue solution, so solution pale green. So what happens? So here this is iron nail is here, and copper sulfate, if we dip inside the copper sulfate, it will be creating ferrous sulfate, and copper will be precipitated. Reddish brown copper deposit on the nail. So this is the copper, reddish brown copper will be coming out, right? So this is example of the displacement reaction. So we can see here, here we have seen that Fe is replacing copper. So obviously Fe is more reactive than copper. So this is very important from exam point of view. Reactivity here, hierarchy we can see. Potassium is is the most reactive. Then sodium, calcium, magnesium, aluminum, zinc, ferrous, lead, hydrogen, copper, Ag, and this is silver, and finally gold. Gold is the least reactive, as we know that's why that is one of the reasons why we use gold, gold and silver. So we can see here what is happening. Double displacement reaction, then double displacement reactions. Ions are exchanged between two compounds, often forming insoluble precipitate. So AB plus CD, here we have two reactants, and it is creating, A is creating with the D, reacting with the D, and B is combining with the C. So it is double, two times displacement is happening. So example is Na2SO4 plus barium chloride here. So what will happen? Na will be combining with the Cl, and Ba will be combining with the SO4. So BaSO4 will be precipitated, and so and NaCl will be there. White barium sulfate precipitate form instantly. So this is a famous compound, BaSO4 white precipitate, also called precipitation reaction. Okay, so this is also done here. Displacement and double displacement reaction, very important from exam point of view. Now let's see what is oxidation and reduction reaction. So here many reaction involve one substance getting oxygen, right? One substance getting oxygen or losing hydrogen, another substance losing oxygen. So what happens here? So if that is the case, right? If suppose here copper oxide plus hydrogen is there, what is happening here in this reaction? You can see oxygen is coming out, right? So this is here, what is happening here? Copper oxide is reduced to copper, right? And here copper oxide loses oxygen, it is reduced to copper, and hydrogen gains oxygen. So this is redox reaction. So copper oxide is reduced, oxidation of is happening to H2, and CO, and reduction is happening to CO. So oxidation, gain of oxygen. What is oxidation? It is a gain of, we will be formally define it with other example. So gain of oxygen or loss of hydrogen is called oxidation, and loss of oxygen or gain of hydrogen of a substance during a reaction, so that is reduction. So here loses here copper oxide loses oxygen, so obviously it is a reduction, right? And here H2 is, hydrogen is getting one oxygen, so it is oxidized, being oxidized, it is oxidized to water. So H2 is oxidized to water, oxidized to water. And here you can see copper oxide is reduced. So this is reduced. Okay. So this is oxidation and reduction, very easy. Very easy. This one is. Then let's understand next one. Next, corrosion rancidity. So what is corrosion? You know, metal is slowly eaten away by reaction with the air, moisture, and chemicals. So for it's every day we see that rusting is rusting. How the rust form? From reddish brown hydrated iron. So Fe2O3xH2O. So this is the water. Water is also there. You can see here. So this one is here FeO, a new compound for FeO, Fe2O3 plus XH2. So this is the rust, and it is reddish brown color rust, right? And silver articles turn black, copper turn green. So different. It's not only iron. The other silver also corrodes, and it become black when we see that when, like, everyday example I am going to give you, like पायल आप देखे होगे सर, जो लेडी इंडियन लेडी जो पहनती हैं पायल, तो वो भी क्या हो जाता है, वो ब्लैक हो जाता है. कॉपर जो है सिमिलरली कॉपर जो है, जो आपका चर्च और इसके ऊपर आपको देखते होंगे, तो ये जो है वो भी कॉपर, वो भी ग्रीन कोट बना लेता है और ये बहुत डेकोरेटिव भी होता है. इट्स नॉट लाइक हियर रस्ट ऑफ आयरन, रेदर इट इज वेरी डेकोरेटिव ऑल्सो. सो प्रिवेंटिव, ये यूरोप में इस तरह का बहुत सारे आर्किटेक्चर हैं, जो बिल्डिंग्स हैं, जो कि आपको इसमें की ग्रीन कोटिंग लग जाता है और बहुत डेकोरेटिव लगता है. सो प्रिवेंटेड बाय पेंटिंग. हाउ टू प्रिवेंट इट? यदि हम लोग देखते हैं कि घर में यदि कोई करोड होने लगता है, आयरन का गेट है या कुछ भी, तो हम लोग उसके ऊपर पेंट कर देते हैं या फिर उसमें वायरिंग करके गैल्वेनाइज करते हैं, है ना. तो उसमें फिर एलॉइंग करके उसको प्रोटेक्ट करते हैं. सिमिलरली यहाँ पर लास्ट पार्ट है रैंसिडिटी. फैट्स एंड ऑयल इन फूड गेट ऑक्सीडाइज ओवर टाइम, स्पॉइलिंग स्मेल एंड टेस्ट. ये बहुत हम लोग देखते हैं. प्रिवेंटेड बाय एडिंग एंटीऑक्सीडेंट एंड फूड. सो इसमें स्मेल आ जाता है, जो फूड है ऑयल है, उसमें फूड गेट ऑक्सीडाइज ओवर टाइम एंड ऑल्सो स्लोड बाय स्ट्रॉन्ग फूड इन एयर टाइट कंटेनर. सो इसका एक चीज है कि उसको ऑक्सीजन चाहिए, तभी वो उसका क्या है कि इस तरह का ये होगा, तो अभी वो खराब होगा. तो एयर टाइट कंटेनर यदि रहे, रेफ्रिजरेशन कर दें, पैकेजिंग इन नाइट्रोजन गैस कर दें, तो रैंसिडिटी नहीं होगा, उसमें स्मेल भी नहीं आएगा, स्पॉइल नहीं होगा. So chapter recap. What is reaction? Forms a new substance spotted by color, gas, precipitate, heat, change. All these are signs of reactions. Something is happening. Some reaction is taking place. Balance every equation. So then we have seen that left side and right side, all the atoms should be balanced. Atoms cannot be created, destroyed. Okay. So 5 reactions type: oxidation combination, we have seen decomposition, displacement, double displacement, and finally we have seen oxidation and reduction, redox reaction. Oxidation in daily life, so the corrosion, rancidity, ये सब एग्जाम्पल हैं ऑक्सीडेशन डे टू डे लाइफ में हम लोग जो देखते हैं. ठीक है, तो आज हम लोग बस यहीं पर रुकते हैं.